two eminent speakers, Dr. Rakesh Gar from the prestigious All India Institute of Medical Sciences and Dr. Sudhir Kannan, who is from Government Medical College, Bangalore. Sir, I welcome you to this meeting.
Thank you very much, sir.
I welcome today's coordinator, Dr. Vijesh and Dr. Rajesh, who is coordinating all our meeting in an excellent way. Welcome, Dr. Rajesh and Dr. Vijesh. I also take this opportunity to welcome our National President-elect, Dr. Venkatagiri, and our Secretary, Dr. Bill Isaac. Without wasting our time, we straight away go to the academic session. And Dr. Giri, a few opening remarks. Dr. Giri, please.
Good evening, President Dr. Nasser, Secretary Binil, our faculties, Dr. Gurudat, Dr. Rakesh, and Sudesh, the academic coordinators, Vijesh and Rajesh. Good evening, all. As routine, we are going ahead with the weekly academic program of ISA Kerala for the PGs, which is getting more and more popularity. Today we have very eminent faculties, and the popularity shows by the attendance. In the beginning itself, we have nearly, or now it must have crossed 150 participants, and people are eagerly waiting all the faculties, Dr. Gurudat, Dr. Rakesh and Kannan. And good, it is our endeavor that the PG should get the benefit of good faculties and get well trained in anesthesia. In that we are going ahead. And I thank our faculties for agreeing for coming to this webinar or the PG classes of this week and spending their time. And wish that more and more PGs will join in the coming days, because today I got a message from one of the cardiac anesthetist faculty from RFA telling that, sir, please always tell that, include my name also. Our PGs also want to join that. So it is not only Kerala, from all over India, PGs are participating. So once again, I welcome all for this academic program. There are many faculties which I don't want to wish to name all the things, all the people today. And welcome all senior members, faculties and PGs. And thank you all. And let's go for the academic program, starting with Dr. Gurudat. And the next part will be next week. I think it is not a 1 week program. It is a part 1 and 2. Today is a part 1, and this part 2 will be the next week's program. Thank you. Over to you, Binil.
I request Dr. Rajesh and Dr. Vijesh to take over the academic sessions. Please.
Dr. Rajesh,
Dr. Rajesh, am I audible? Dr. Rajesh,
yeah, now it's audible.
Yes, clearly. Just start out.
Dr. Rajesh, it's not audible now.
Sir, you are muted, sir. Rajesh, sir, you are muted.
Dr. Rajesh, yes, sir. Rajesh, sir, is muted, I think.
Yeah, is it okay now?
Now it's okay.
It's okay.
Yeah, thank you. Today we are very fortunate to have none other than Professor Gurudat sir. As his name implies, he's very generous and caring towards the students. And every year he used to conduct update program at his home residence. And PGs used to come out very exam prepared, very competitive at the end of his sessions. Today, so we are very fortunate to have him now, and he's planning to take it in 2 sessions. Today he's planning to do it anesthesia machine, and I was told in the next week also he's planning to do with the workstation. Over to Gurudat sir.
Yeah, thank you, Rajesh. I'll just share the screen.
Okay, sir.
Is it visible?
Yes, yeah, sir. You are
Yes,
visible.
sir.
Is it okay now?
Yes, sir.
Yes, sir.
Okay. Shall I start, Rajesh?
Yes, sir, please.
Okay. Good evening, everybody. And, first of all, my thanks to ISA Kerala. They are doing fantastic work, conducting PG update every Saturday for the past, I think, many months now. And majority of the PGs of all over India, they are taking part and they are highly benefited. So we should really appreciate the efforts from the ISA Kerala for this. And also would like to thank Dr. Venkatgiri, the president-elect of ISA. So actually he asked me about maybe about 20 days back that I should take classes for the PGs in this PG update regarding the anesthesia machine. So he was so generous, he asked me to take this classes for 2 weeks. So I have divided today also I'll be talking for about an hour, and probably next week, that is on 27th also I'll be talking about for maybe about 40 minutes or 1 hour. So thank you, Venkatgiri, for this generosity. And also I would like to thank Vijesh and Rajesh for this opportunity that has been given to me so that I can reach many other postgraduates and I can teach them regarding the anesthesia machine and workstation.
It is an honor for us, and
Pardon?
it is an honor for us you being with us. You are a real guru for all of us.
Thank
Really,
you.
you are my guru when I was doing PG. You were the final year and I was, and you are the guru for everybody. It's an honor you being with us. Thank you.
Thank you, Giri. Thank you so much. So I also would like to bring greetings from Mysore and the JSS Medical College Hospital, where presently I'm working. Just one thing I just want to tell all the postgraduates, because anesthesia machine and workstation are usually an enigma for majority of the students. Now, when I used to conduct the DNB classes for the DNB students, exam going students of DNB. So every 6 months. So the first day they come, and then the second day itself they'll start asking, sir, when are you taking the class on anesthesia machine? Because many of the PGs do not know much about the anesthesia machine and workstation. And even our PGs, when I go into the OT, I keep asking them some questions about the anesthesia workstations and machine. So they'll not be answering because they'll not know much about the anesthesia machine and workstation. Every day they're using. See, if you are using an equipment and if you don't know much about the equipment, definitely you'll not be very safe for the patients. It is very important that you know about your equipment so that you can be very safe to the patient. For that purpose, you have to know more about this anesthesia machine and the workstation. The second thing is very important is, many questions are asked for you in the practicals, and also even in theory, individual parts of these workstations are asked for short notes. Because of that, you have to have a good knowledge about the anesthesia machine. So let us start discussing about the anesthesia machine and workstation. So today, probably I'll be discussing with you till the high pressure system. So the next week I'll be talking to you regarding the intermediate and the low pressure system of the anesthesia workstation. See, when W.T.G. Martin, William Thomas Green Martin, introduced anesthesia to the world, that was on 16th October 1846. Even today, we celebrate this day as the World Anesthesia Day. So that was in Massachusetts General Hospital, and the patient was Gilbert Abbott, and the surgeon was Warren and Bigelow. So, successfully a vascular tumor was removed, and the patient didn't know anything about the pain or anything. He was very well anesthetized, and the Bigelow said that this is no humbug, and anesthesia was born. And why I just wanted to tell you about this is, you can see here in this picture, Martin is holding a ether flask, a simple ether flask he was holding, and he was not using any sophisticated anesthetic equipment for anesthetizing the patient. So same thing continued for a long time, because only volatile anesthetic agents were being used for providing anesthesia. Simple Schimmelbusch masks were used, or even many times the handkerchiefs were used for providing anesthesia using open drop ether method or open drop chloroform method. So for many years there was no requirement of an anesthesia machine as such. But later in early 1900s, so many of these gases, especially the oxygen, carbon dioxide, so the nitrous oxide, and even cycloform, these were introduced in compressed form. So when these gases were introduced in the compressed form in cylinders, so then there was a requirement of an anesthesia machine. So why? Sometimes they do ask you a question about the compressed gases. So, you should always answer when you are asked about the definition of a compressed gas. A compressed gas is any gas that is stored in a container with a pressure of 40 psi at or above 40 psi or pounds per square inch absolute at 70 degrees Fahrenheit. A liquid gas having a pressure of more than 40 psi at 100 degrees Fahrenheit. So this is the definitions of compressed gas. Many times I've asked many of the PGs, they'll not be answering this. You just remember about the definition of the compressed gas. So when these gases were introduced in the form of compressed form and then as in the cylinder form, so there was a requirement of a metal frame onto which these cylinders could be mounted, and then a mixture of these gases, a definitive mixture of gases, could be provided to the patient to provide anesthesia. So that requirement of the anesthesia machine was fulfilled by none other than Henry Edmund Gaskin Boyle. So this is another question they'll ask you: who introduced the anesthesia machine, the first introduction of anesthesia machine by whom? So, and also when. So this was introduced in 1917. So the manufacturers of this first anesthesia machine were British Oxygen Company Limited. So they were very magnanimous and they gave the name of this machine to Boyle himself. They credited the name to Boyle, and the machine is was called as the Boyle machine. And even today, if you ask any of the old surgeons about the anesthesia machine, they still call it as the Boyle machine. Of course, now you know that this old anesthesia machine has come a long way, and now what we presently use is anesthesia workstation. So one of the questions that is commonly asked for the postgraduates in the exam, especially in the practical exam, because in the practical exam you have the old anesthesia machine also will be kept, and by the side of it we do have the anesthesia workstation as well. So they'll be asking the difference between the anesthesia machine and the workstation. So there are many differences. So one of the most important difference is, anesthesia machine is purely a pneumatic component it has. So whereas the anesthesia workstation has the pneumatic component, the electrical components, and also the electronic component as well. So the second difference is the workstation has an integrated ventilator, and also it has got integrated monitors, which the anesthesia machine doesn't have. And the third most important difference is the safety features. Many of the safety features which have been included in the pneumatic component of the anesthesia workstations were not there in the anesthesia machine. And all these safety features have been included mainly to prevent a hypoxic mixture being delivered to the patient. And these safety features are very important for the exam purpose. And many times, many of the examiners are very fond of asking you people regarding the safety features that have been included in the anesthesia workstations. So that all over the world, two giant companies manufacture these workstations. One is the Datex Omada GE and the other is Draeger. There are a few differences between Datex Omada and Draeger as far as the pneumatic system is concerned. So you have to know about this, because in one of the OTs you may have a Draeger machine, another OT you may have a GE machine. It is always better to know about the differences between these two. So while I'll be talking to you especially about the intermediate system and the low pressure system, I'll be talking to you about the differences between these workstations as well. So I told you that the pneumatic system is very important, because the pneumatic system only all the safety features have been adopted. So we have to know more about the pneumatic system of the anesthesia workstation. So this pneumatic system, majority of you know that it has been classified into the three circuits or three systems: the high pressure circuit, the intermediate pressure circuit, and the low pressure circuit. The high pressure circuit is mainly from the cylinders up to the pressure regulators. You have the high pressure circuit. From the pressure regulator downstream up to the flow control valve, you have the intermediate pressure circuit, and down the flow control valve up to the common gas outlet, or in workstations up to the closed circuit, we have the low pressure system or low pressure circuit. Now, what is the pressures in these systems? In the high pressure system, it is the cylinder pressures. We know that oxygen service pressure of oxygen is roughly about 1,900 to 2,000 psig. That is a pounds per square inch gauge pressure. And the vapor pressure of nitrous oxide at 20 degrees is 750 psig. So this is the pressure in the high pressure system. So as the gases pass through the pressure regulators, the pressures are reduced into the intermediate pressure system. So in the intermediate pressure system, the cylinder pressure is reduced to 45 psig. In the meantime, into the intermediate pressure system, the pipelines are also attached. So the pipelines are part of the intermediate pressure system. The pipeline pressure is roughly between 50 to 60 psig. Now, there is a deliberate difference between the reduction of the cylinder pressure and the pipeline pressure. So this is another common question that is asked for you in the examination. Why there is a difference between the pipeline pressure nearly 60 psi and cylinder pressure is reduced to only 45 psi. So the thing is, suppose I have opened the cylinders first, because these cylinders are always kept as backup cylinders. So, but once I want to start my case, I have to open the cylinder and check whether I have got enough of backup pressure in the cylinders or not. Suppose I have opened this cylinder, actually I should close the cylinders. But suppose I have forgotten to close the cylinder, I have opened these cylinders as well as I have connected the workstation to the pipeline supply. Now, the question that is asked for you in the exam is, which gas is preferentially used? Is it from the pipeline supply or from the cylinder supply? Now, because of this deliberate difference in the pressures, the pipeline supply of the gas is preferentially used by the workstation and not the cylinder supply. The pipeline pressures also will stop the flow of the gases from the pressure regulators also, because they're going to build higher pressure inside the pressure regulator, inside the chamber of the pressure regulator, so that the flow of the gases from the cylinders cannot occur. So that way, definitely the pipeline supply is preferentially used. So that should also occur. So this is one of the safety measures that has been adopted in workstations, which was not there in the older machines. Because in the older machines, the pipelines are also connected to the same yoke. So if the pipelines are also connected to the same yoke at a pressure of 60 psi, and the cylinder pressure is much, much higher. So when you keep that open, both the things are open. So naturally, the cylinders get emptied first and not the pipeline. So that is the reason in the older machine, this safety feature was not there. Now the safety feature has been adopted in the newer workstations. But one thing you should always realize, even though this safety feature is there, still you do not keep the cylinders open when you want to use the pipeline gases. That is because, one problem is there can be fluctuation of pipeline pressure. Sometimes it can even come down below 45 psig. So once there is a decrease in the pressure of the pipeline system, then the cylinder supply of gases will be used up by the workstation. That is one thing. The second thing is, that suppose the pipeline pressures are exhausted, now the cylinders will start getting used up, and cylinders also get exhausted. Now you get an alarm, then only you get an alarm till the cylinders have got the gas and the pressure, the alarms will not sound. So when the alarms sound, now you try to open your backup cylinder, the backup cylinder is already opened and exhausted. So that is the reason you have to make sure that before you start the case, you first open and check the cylinder pressures and then close it. So the next thing is the low pressure system. So the pressures in the low pressure system is just about 5 to 8 psi, just above the atmospheric pressure. Now let us discuss about the each system. Now coming to the high pressure system, mainly the components of high pressure system, you have the cylinders, the hangar yoke assembly. Inside the hangar yoke assembly, you have the check valve also, and you have the pressure gauges and the pressure regulators. So a lot of questions will be asked for you regarding the cylinders. So I made it a point to in detail to explain about these cylinders. So many times one question is asked about to name, just a simple question to name the parts of the cylinder. Now the cylinder has got a body, it has got a shoulder, and the shoulder is very important because many times the shoulder is the one wherein the color coding is done, and then the neck of the cylinder, and into the neck, so the cylinder valve is threaded or screwed inside the neck of the cylinder. So these are the parts of the cylinder. The valve is a separate entity when compared to the cylinder proper. So another very important safety features of these cylinders are, they are made seamless. Seamless means there are no joints. So this is another very important safety feature. So you will be asked about, and if there is a joint, it is a weak part of the cylinder. It can give way because high pressure gases will be there inside the cylinder. Like 2000 psi is a very high pressure of oxygen. So seamless body is very, very important. So next is what is the metal or the alloy with which the cylinders are made of? This is another common question that is asked. So initially the cylinders were made with hand forged steel. So this was the alloy that was used to manufacture the cylinders. The main problem with this hand forged steel was it had less tensile strength. So because it had less tensile strength, the walls had to be made very thick. So because the walls had to be made very thick, it used to weigh very heavy. And the second was the capacity or the volume inside was less. Now presently what we have is the molybdenum steel. That is the one which now presently the cylinders are made of. The molybdenum steel, it has got a high tensile strength. It is lightweight. Because of high tensile strength, the walls could be made slightly less thicker, and because the capacity could be increased, it could contain 20% more gas. We also have aluminum cylinders for MRI suits. The other question that can be asked is, what are the engravings on the cylinders? So this is another common question that is asked, that markings on the cylinder. So usually the cylinder, the front of the cylinder and the back of the cylinder. Usually we say the front of the cylinder means the cylinder is facing the machine. The front of the cylinder, you can see one thing is that what is written is the DOT. DOT is Department of Transportation. So if the Department of Transportation has definite specifications for the manufacture of the cylinders, so if the cylinder satisfies all these specifications, then they'll mark it as DOT. That is very important. So next to DOT, it is there as 3AA. 3AA means it is made of steel. And another very important thing next to 3AA is 2015, that is written, that is the service pressure. 2015 pounds per square inch is the service pressure. So sometimes you'll be asked, what is this service pressure? Now, service pressure is the maximum pressure with which a cylinder is filled for supply and to be used. So this is what is service pressure. So another important thing, on the back side of the cylinder, you do have certain engravings, especially the elastic expansion of the cylinder when they do a hydrostatic test. You can see here 17.5 cc at 3360 psi. Because this 3360 psi is again important, it is usually 1.6 times the service pressure. So usually they check the cylinder's tensile strength with making the cylinder to have a higher pressure of 1.6 times the service pressure. You can see if you multiply this 2015 by 1.6, you get this 3360. So that is the pressure at which the cylinders are usually checked. So you have also sometimes some of the cylinders, you can see the dates on which the cylinders are checked. So that is also there in some of the cylinders. But in Indian cylinders, you don't have these dates are not there on the cylinder, but usually there will be the plastic disc or the metal disc that is just between the cylinder valve and then the main body of the cylinder. So many of the students would not have seen this disc at all. So on this disc, it is engraved when the date of testing of the cylinder. So it is very important to know that this particular, the disc. So tomorrow, day after tomorrow, once you go to the OT, you just see the cylinder and see whether this disc is there or not. And this disc is important to know about. So I told you about 3AA, that is the steel. So another thing is 3AL if it is written on the cylinder, or 3ALM is written on the cylinder. It shows that the cylinders are made of aluminum. So in a nutshell, the markings engraved on the cylinder is the service pressure, dates of test, and the chemical formula of the cylinder's content, whether it's nitrous oxide or whether it is oxygen. And another very important thing for us is the tear weight. The tear weight is nothing but the weight of the empty cylinder. So I'm going to talk to you later about why this tear weight is important. This is especially important when you have the liquid gases like the nitrous oxide and carbon dioxide, because by the pressure gauge, you will not be able to know how much of nitrous oxide is available for you or how much carbon dioxide is available inside the cylinder, because the pressure gauge will not dictate, or it will not show you how much volume of gas is present. So we'll just talk about this tear weight later. So the sizes of the cylinders, they are usually named based on the alphabets. So either it can be from A, B, C, D like that. So what we have is usually the D cylinders and the E-type cylinders are the ones which can be mounted onto the workstation because they do have pin index. Whereas the larger cylinders like F cylinders is the wad cylinder. The H cylinder is the one which is the very largest cylinder and contains the highest amount of capacity of the gas, and it is the one which is used as the bulk cylinder in the manifold for the pipeline system. And here you can see the tear weight also. I just showed you the tear weight of the empty E-type cylinder is about 5.4. So I'll let you know later why this is important. Now regarding the color coding, the color coding was the international color coding was first introduced in 1949. And we all know that in that international color coding, so both the bodies and the shoulders were color coded. Like oxygen is black body with white shoulders, nitrous oxide is blue and blue, and carbon dioxide is gray throughout both the shoulders and the body. Cyclopropane is orange, and the helium is brown, and Entonox blue body, and the neck is white and blue. But in 2010, a new international color coding has been introduced. It has been used in already in other countries. In India, we have not started using this. Now, especially for medical gas cylinders, the bodies of all the medical gas cylinders are now colored white. Now, if you want to know which gas a particular cylinder has, you have to look at the shoulders. If you see, this is the oxygen cylinder, the body is white, the shoulder is also white. Whereas nitrous oxide, the body is white, whereas the shoulder is blue. So, like helium, the body is white and the shoulders are brown. And, the air, the body is white and the shoulders is white and black. So it is always like that. And, Entonox, again, the shoulders are blue and white. And, and one capital letter N is also etched on the shoulders of these cylinders. That shows that this is a new international color coding. So just remember about this new international color coding. You may be asked about, because the original color coding was introduced only in 1949. So it's a long time. So only for medical gases, this has been changed. Now coming to the cylinder valves, I told you cylinder valves are separate from the body of the cylinder. So they are screwed into the neck of the cylinder. So usually the cylinder valves will have two surfaces. You can always say the inner surface and the outer surface. The inner surface is the one which is facing the machine. Outer surface is the opposite to that. So the from the outside, if you just see, you can see a stem, and you can also see a gland nut just below the stem, and you also can see on the outer surface a conical depression wherein the tip of the retention screw will be there for tightening, And below that, you have a pressure relief device. I'll be talking about this pressure relief device that is very important. And on the inner side, where it is cylinder is connected onto the yoke of the machine or the workstation, you have the port, and just below the port you have the pin index holes or pin index safety system. So whatever these cylinders that we are using, both the large cylinders and the small cylinders are of flush type. Also, they are called as direct acting types or packed type. So these are known as packed type or direct acting type or flush type of cylinder valves. Now this is a longitudinal section of the cylinder valves. Now you can see the spindle here, and you can also see the packing nut, or otherwise also it is called as a gland nut. And now in between the space is filled with Teflon, and that is tightened by using the gland nut. And below that you have a seat, the valve seating. So when we rotate the spindle in an anti-clockwise direction, so at least 3 or 4 rounds if you rotate, the seating will release the gases to move out of the port. Now one thing again, it's very important for you to know that you have to turn only the spindle or the stem. So because in one of the examinations, practical examination, I had gone to one of the centers wherein I asked the students, all the students were trying to open the gland nut, the packing nut. You should never do that, because you're going to produce a lot of the leakage of the gas. None of the students knew about how to open a cylinder. Just imagine. So that means they have never checked whether the backup cylinder is there or not. So these are very important things. Should always rotate the spindle or the stem. Now on the opposite side, that is the outer side, you have a conical depression, and below the conical depression you have the safety relief device. So one thing about the smaller D-type and E-type cylinders, or the port that is there, it is a female port. So it accommodates the nipple of the yoke. Whereas in larger cylinders, the port is a male type of port, and that non-interchangeable screw thread connection will be there for the pipeline here. That is the difference between a smaller cylinders with pin index safety system and the larger cylinders. Otherwise, these are also packed type of cylinders only. Now coming to the pin index safety system. So this is another very important thing. Who introduced the pin index safety system and in which year? So pin index safety system was introduced by Philip Woodbridge. That was in 1952. So actually commercially was made available from 1956. Now you can see the holes are made on the cylinder valve just below the port. This is the port, and exactly at about 9/16 of an inch below the port, from the center of the port, now the holes are made. From the left to right, the holes are numbered 1 to 6. And if you want to know in millimeters, it is roughly about 14.3 millimeter. That means every hole, the center of every hole will be about 14.3 millimeters, or by 9/16 of an inch from the center of the port. And the holes are made in such a way that each hole is overlapping the other. Like 1 is overlapping the 2, 2 is overlapping the 3, but 3 and 4 will not overlap. 4 will overlap about 5 over 5, and 5 will overlap over 6. But 3 and 4 are overlapped by the 7. So this is what again you have to know, because even pin index safety system has been asked for short notes also for you. So the measurements are very important, and the numbers are also very important. So another important measurement about the pin index holes is the hole is about 4.75 millimeter diameter. The pins will have a 4 millimeter diameter, so that the holes can easily accommodate the pins, and the length of the pins is 6 millimeters. So these measurements always remember. So these pins of the yoke have to align with the holes of the pin index safety system. Then only you can fix a particular cylinder onto a particular gas, the yoke side of that particular gas of the anesthesia workstation. If the pins and then the holes do not align, you will not be able to fix. So this is one of the very important safety systems of the anesthesia workstations. So what are the pin index numbers? Now we have for oxygen it is 25. These three are very important: oxygen, nitrous oxide, and air, because these are available as D and E type cylinders. So usually mount them onto our workstation. So oxygen is 25 number, nitrous oxide is 35, then air is 15. So as long as the 5 number is common, the 5th hole is common for oxygen, nitrous oxide, and air, whereas only the first hole, that is the left side hole, is different. For air it is 1, and for oxygen it is 2, and nitrous oxide is 3. So it is easy to remember. Of course, Entanox is very easy to remember. It is a 7. Sometimes they may ask you about carbon dioxide. It is 1,6 for carbon dioxide. Now another safety feature, which is very important for again exam purpose. Now these cylinders always to be kept in cold areas. They should never be kept in sun. So suppose if they are kept in sun, what will happen is the gas inside the cylinder will start getting heated up. Now once the gas starts getting heated up, now you know that the cylinders will have a good tensile strength. The volume cannot increase. So if the volume cannot increase, what will increase? The pressure will increase based on the Boyle's law, because the Boyle's law says that the pressure and volume are inversely proportional to each other. So once the volume cannot increase, the pressure increases. So in the meantime, what will happen is, now the temperature and pressure are directly proportional to each other based on the Gay-Lussac's law. So pressure, volume, and temperature are directly proportional to each other by Charles' law. So because of all these, the pressure inside the cylinders will start increasing, and once the pressure reaches a critical pressure, so cylinder can even explode, or even it can burst. So it can produce quite a bit of collateral damage to nearby people. So in order to prevent that, what we have is we do have a pressure relief devices. So these pressure relief devices, there are various types of pressure relief devices. They are mainly present, I told you in the beginning, present just below the conical depression. So the conical depression is the one wherein the tip of the retention screw will be accommodated. Just below that, we have the pressure relief device. We have a ruptured disc or type of fusible plug, or a combination of both ruptured disc as well as the fusible plug. The another type, the fourth type, is a spring-loaded pressure relief valve. So we'll just discuss about each one of them. So a fusible plug, especially this, it has the Wood's alloy inside, so or a Wood's metal. This is many times asked for you in the exam. So what are the components of the Wood's alloy or Wood's metal? It's basically made of cadmium, bismuth, lead, and tin. So the specialty about the Wood's alloy is that it melts at a lower temperature of 150 to 170 degree Fahrenheit. See, once the gases inside the cylinder gets heated up, the temperature increases, so the Wood's metal will melt, and then it will vent the gases so that it will prevent bursting of the cylinder or even explosion of the cylinder. So the second thing I told you is about a ruptured disc. So this ruptured disc mainly has the thin copper disc, and whenever the pressure inside increases, so once it reaches a critical pressure, the disc will rupture and vents out the gases inside. Both these, fusible plug and ruptured disc valves, they are non-closable valves. That means they don't close. Once they open up, so you will have to send the cylinder, because you cannot use that cylinder. So that has to be again repaired, or a valve has to be replaced. Then only that cylinder will be can be used. So the fourth type of the valve I told you is a spring-loaded pressure relief device. So in this, you have a seating, and also you have a spring. So whenever the pressure increases, the seat is it is going to push the spring away, so that the openings will be there for the gases to escape. So once the pressure drops, the spring will push the seat backwards, and it is going to close the vents, so that this is a reclosable type of pressure relief device. So with this pressure relief device, you can reuse the cylinder without much problem. But these are usually not very popular pressure relief devices, because they may not function properly. So because of that, majority of the times, a combination of ruptured disc and fusible plug are the most popular pressure relief devices that are used. But if you are asked in the exam about our Indian cylinders, where is the pressure relief device? So if you are asked about it, if you are trying to look for the pressure relief device underneath the conical depression, you will never find it because it is not there. So in our cylinders, what they do is, the cylinder valve has got a threaded bottom is there. This is screwed inside the neck of the cylinder. When it is being screwed inside the neck of the cylinder, in between these the cylinder valve and the inside of the neck, Wood's metal is incorporated. So whenever the cylinder temperature increases, the Wood's metal melts and the gases can be vented out. That's what you have to tell in the exam regarding the what is the safety feature that is adopted in Indian cylinders. So one more thing you'll be asked is cracking the cylinder. So many times this is one of the common questions asked by many of the examiners. So what is cracking of the cylinder and how do you crack the cylinder? Now cracking of the cylinder means, when the cylinders are transported, ideally the cylinder valves have to be covered. So many times the cylinder valves, if they are not covered, there can be dust inside the port. So if you just mount the cylinders without cracking and open the cylinders, so what will happen? These dust can block the narrow piping inside, and the flow, it can obstruct the flow. Second thing is the dust particles may catch fire and there can be an explosion. So what you have to do is, before actually fixing the cylinder onto the workstation, so you have to open the cylinders outside, and then only after leaving some amount of gas for a few seconds, then only you have to mount the cylinder onto the workstation. So when you are opening, because many times I've seen some of the examiners asking the student to crack the cylinder in the exam. So they'll give the cylinder, and then they'll ask you, come on, open the cylinder and crack it. So when you are opening the cylinder, we will be watching you how you are opening the cylinder. It is very important that your head should not be above the cylinder valve. So you have to incline the cylinder opposite to you, and then only you have to open the cylinder valve. Because this is again a safety precaution you have to take. If this cylinder valve is loosely fitted, because once you try to open, so that because of the high pressure, the cylinder valve can gain momentum and it can, with great velocity, can hit your head. So this is another thing for the exam purpose you should always remember to know about. Now, once you mount the cylinder, how do you open the cylinder? This is another question that is commonly asked. So when you mount the cylinder, when you want to open it, you have to open it very slowly. Never open rapidly. This is another common question again asked is, why should you open very slowly? So if you open rapidly, what is the problem is, when you open the cylinder, the gases have to flow through the yoke assembly and then to the pressure regulator. So in between the yoke assembly and the pressure regulator, the space is very, very narrow. So what will happen is, when you open it rapidly, so large amount of gas gets compressed in the narrow space in between the yoke assembly and the pressure regulator. Whenever it gets compressed, so it gains a lot of heat. So, but there is no time for the heat to be dissipated. So this is what is called as adiabatic process. Adiabatic process is the one wherein there is a change in the state of the fluid, and whatever the heat energy that is released, there is no time for dissipation of this heat energy. So this is called as adiabatic process. So they'll ask you about this adiabatic process, and if because of the large amount of heat that is gained, so if there are any particles, I told you about cracking of the cylinder, if there is any dust particles, they may catch fire and there can be an explosion. So this is why you have to open the cylinder slowly and not rapidly to prevent adiabatic process to occur. Now coming to the tests for the tensile strength of the cylinder. So various tests are done, and usually these tests are done once in 5 to 10 years, and 100 cylinders of that batch, out of 100 cylinders, one cylinder is tested, and I told you a plastic ring around the cylinder will indicate the time of the testing and next testing. So there are many tests, like, you have the hydraulic testing, you have flattening test, you have the impact test, you have bend test. So in that, the most popular is the hydraulic testing. So in this hydraulic testing, it is a very simple test. So what they do is, they introduce this cylinder into a water jacket. You can see the water jacket outside. So this water jacket is connected to a, the glass tube, which is the graduations are there in the glass tube. So once the cylinder is introduced here, so the level of water in the graduated tube will rise. It will go up. Now what they'll do is, this cylinder will be connected to a water source. The water is pumped into the cylinder, and the pressure inside the cylinder is increased to 1.6 times the service pressure. That's what initially on the markings of the cylinder I was telling you. It is the pressure increased inside is 1.6 times the service pressure. So if the tensile strength is poor, it is going to yield. The cylinder is going to yield, and it is going to expand. Once it expands, the gauge here, it will be showing a higher level of water. So this is what is called as hydraulic testing. It's a very simple test. Whereas for other tests like impact test and bend test, you have to break open the cylinder and you have to do the test. So majority of the times, the hydraulic test is the most popular test that is being done. Now, another question you can be asked is how these gases are filled. So oxygen, usually it is filled. It's a gas because it is the critical temperature of oxygen is -118 degrees, and at room temperature, the oxygen is always remains as a gas because it is much higher above its critical temperature. So filling is very easy. So they just fill it to the service pressure. So of 1900, 2000 psi. So once it reaches this pressure of service pressure, they'll stop filling it. Whereas for nitrous oxide, because it's a liquid gas at room temperature, because its critical temperature is 36.5 degrees. So room temperature at 20 degrees, it always remains as a liquid. So it is based on how it is filled is based on the filling density. Now, what is filling density? This is another question it is asked for you. It is nothing but weight of nitrous oxide divided by weight of water. Because in an E-type cylinder, the volume inside or the capacity inside is about 5 liters. Because the water density of water is 1, so the 5 liters of water will weigh 5 kgs. So you can see here the denominator will be 5 kgs, and the filling density in tropical climates and countries, the filling density is 0.68 or 68%. So now once you know the filling density and you know the capacity of the cylinder 5 kgs, you just multiply this 5 with this 0.68, you get the weight of nitrous oxide that is present inside. That is 3.4 kgs or roughly 3.3 kgs of nitrous oxide will be present when it is completely filled. So when it is filled, you should always know that it is not filled completely because it is a liquid. So only about 90% when 3.3 kgs of nitrous oxide are introduced into these cylinders, almost about 90% of the cylinder is filled. Almost nearly about 5 to 10% of the space is kept vacant for nitrous oxide to vaporize. So it is not completely 100% it is filled. This is also an exam question. What is the percentage of nitrous oxide cylinders are filled? They are filled based on the filling density, and the percentage is filled is about 90 to 95%. So above that, you require for vaporization of the cylinder. Now, in a nutshell, the safety features of the cylinders, that they are made of molybdenum steel, the color coding is there, seamless body, safety relief valve, and the pin index safety system. So coming to the hangar yoke assembly, now, this is an older hangar yoke assembly. Now, this is a newer one. So with modern workstations, these parts of the hangar yoke assembly, you have, the body of the hangar yoke assembly. You have a swivel gate also. Many of the hangar yoke assemblies will have. So you have the retaining screw, then the pins for the pin index safety system. You have the Bodak seal. You have the nipple for the port of the cylinder to be connected. And inside the hangar yoke assembly, you have the filter and also the check valve. So what are the functions of the yoke assembly is again an exam question. So the yoke assembly supports and orients the cylinder to the machine. it maintains a leak-proof connection between the cylinder and the machine. This is again important. The leak-proof connection is made possible is because of the presence of the Bodak seal. And another thing is, it maintains a unidirectional flow of gases towards the machine only, and this is mainly by the check valve. In older machines, these yoke assemblies used to be on the sides of the cylinder. Now with the present workstations, these yoke assemblies have been shifted onto the back of the workstations just below the pipeline inlets. You can see there is a swivel gate, and you can also see the Bodak seal inside the yoke assembly. Now coming to the Bodak seal, this is another very important thing. In the exam, you'll be asked about this. So what is it made of? It is made of a very tough rubber, that is a neoprene rubber, and it has got a surrounding of the metal ring of aluminum, and some of them can also have copper metal ring. So this is one thing. The Bodak seal, the importance of Bodak seal is that it is a very tough one, and it won't yield when you are trying to tighten the cylinder. So they have a long life. So that is the advantage of using Bodak seal. So one thing you should remember, that again, you may be asked about this, you should never use more than one Bodak seal, because if you use one Bodak seal, you will definitely negate the safety system, that is pin index safety system. You can overcome that. So that is why you should not open. So another thing I was telling you is about the check valve. The check valve is present inside the yoke assembly, and these check valve, when the cylinders are opened, they'll allow only the gases to flow towards the machine. Suppose you have one more yoke connected, and that yoke, let us say that you have kept it open, and once you have kept it open, if the check valves are not there, there can be the leaking of the gases through the particular yoke assembly. So the other thing is, suppose if you have left a empty cylinder here, there can be transfilling of this empty cylinder. So these check valves will definitely prevent this. And many times what will happen is these check valves may not work 100%. So that is why you should never allow an empty yoke without connecting a full cylinder or plugging it with a yoke plug. So many times you will be asked about this yoke plug, because this yoke plug is always present along with the yoke, and there is a chain is there, and it is connected with a chain to the body of the yoke. So this is, you can see here, it is connected by a the chain, and this is the yoke plug. On one side towards the machine side, it has got a hole which will accommodate the nipple so that it can close the nipple. The other side, it has got a concavity, or the depression is there, so which will accommodate the tip of the retention screw. So this yoke plug is very important. So many of the students will not know about this yoke plug, and they call it as yoke block also. It is not yoke block, it is yoke plug. You can see here the yokes, empty yokes of carbon dioxide or even cyclopropane in the older machines being plugged by using yoke plugs. So you can see the chain also. So it's very important. So when you go to your OT tomorrow, day after tomorrow, just check for yoke plugs are there or not in your workstation. They are very important. So I was telling you, many of the students call that yoke plug as yoke block. So you should always remember to know the difference between yoke plug and a yoke block. So in the older machines, the pipeline is connected to the yoke using the yoke block. So this is, you can see here, shown through the arrow. It is the yoke block, and it is not the yoke plug, where central pipeline is connected to the yoke. So these yoke blocks are almost replicas of the cylinder valves. Now, another common question for you in the exam, you'll be asked about, because if they show you the yoke block, and first they'll ask you to name that, so you'll have to name it as yoke block. And the second thing is, there will be pin index holes on either side of the yoke block. So I've seen used this yoke block with only pin index being only one side. So they are dangerous, because you can invert these yoke blocks and connect to a wrong yoke. So in order to prevent connection of these pipelines to a wrong yoke, so they have made the holes on either side. Even if you invert the yoke block, you'll not be able to connect the pipeline to a wrong yoke. So this is the one is very important for you to answer in the example. So now we know that we do have the pipeline connection separately in the workstations. You don't require a yoke block. So what you have is in the workstations, you have the pipeline inlets. The pipeline inlets are usually just above the yoke assembly, and you can see here the pipeline inlets. So these pipeline inlets are also will have a diameter index safety system. So you have the pipeline system, the pipeline, this is the pipeline with, the connectors are there for the pipeline. The connectors with the pipeline have to be connected onto the inlet of the, bodies of the, on the machine side or on the side of the workstation. So what is very important here is the diameters of the nut and then the stem. Usually you have a nut, you can see the nut here, and then inside is the stem. So the diameter of the nut and stem should align with the inner and outer diameters of the body. So then only you can connect that particular pipeline onto the body of that particular gas inlet. So this is what is called as diameter index safety system. Here, the diameters of both the nuts and the stem are separate. So whereas you do have one more type of diameter index safety system that is called as a nist. Nist is the non-interchangeable screw threads. So these non-interchangeable screw threads, the difference between this and nist, sometimes you may be asked, is that the nuts are not indexed in nist. Only the probes or the stems are diameter index. So the majority of the UK manufactured machines, you have the nist connectors, and the US manufactured machines, you have the disconnectors. So this is on the machine side. What is happening? Okay, in the machine side, again, in the inlet of the pipeline connections on the machine side, you have a check valve also. So that, suppose if you have not connected any pipeline onto this inlet, so if the gases tries to come out, they'll not be able to come out by this check valve. This is again a safety feature that is adopted inside the inlet of the pipeline system. So on the wall side, you do have wall outlets, and these wall outlets are also diameter indexed actually, and they are also color coded. But though they are diameter indexed, you don't call that as a diameter index safety system. The connections are called as Schrader valves. Schrader valves are otherwise also called as quick couplers. Why they are called as quick couplers is because you can rapidly decouple or couple these pipeline onto these wall outlets. So that's why they are called as quick couplers or Schrader valves. So that you should always remember. There is another question that will be asked for you to name these connectors at the wall outlets. Now coming to the pressure gauges. Now we had pressure gauges in the older machines on just above the yoke assembly. Now these pressure gauges have been shifted to the front of the workstation, and majority of the times they may be just below the flow control knobs. You can see these are the pressure gauges for the pipeline system, and these two are the pressure gauges for the cylinder. You can see the symbol is always there for the cylinder. You can also have the pipeline symbol for the pipeline pressure gauges. This is again another safety feature because in the older machines we did not have any pressure gauges for the pipeline gases. Now we do have the pressure gauges for pipeline, and you will know by looking at these pressure gauges how much of the pressure is there inside the pipeline system. Suppose this indicator starts falling, now you know that you'll have to open the backup cylinder. So that's the reason why this is a safety feature that is adopted in your workstations. Now these pressure gauges are called as the Boden's pressure gauge. This Boden pressure gauge, it is a hollow metal tube made of copper, and the tip, it is bent like a C or a J tip, and the tip is J shaped and the tip is closed, and the tip is connected through a clockwork mechanism to an indicator. Now here what happens is Now, once you open the cylinder or the pipeline is connected, so the gases will start flowing through these, the metal tubing. Once the gases flow through the metal tubing, because of the pressure, it straightens. Once it straightens, because of the clockwork mechanism, so the indicator starts moving over the gauge and it will be showing what is the pressure inside the cylinder or in the pipeline system. Now, another question, sometimes these kind of machines are also kept for you in the exam. And, in this machine, if you see, you have only the pressure gauge for oxygen and there are no pressure gauges for nitrous oxide. They may ask you why there are no pressure gauges for nitrous oxide. And we know that we do have pressure gauges nowadays for nitrous oxide as well. So why that is because, the oxygen is a gas, because I told you it is always above its critical temperature at room temperature. And because it is a gas, so because of the universal gas law, that is PV is equal to nRT, the pressure, because volume inside is constant, the R is a constant, universal gas constant, temperature is usually constant. So the pressure directly will give you what is the amount of gas inside. So the pressure gauge actually tells you the content of the cylinder. So that is, if it is the full, then that is 660 liters you can have. So if it is half full, that is, if the pressure is showing 950, you have 330 liters. If it is 1/4 filled, you know that it is 165 liters. And if it is empty, it will be showing the indicator will be showing 0. Whereas with nitrous oxide, it is not like that. With nitrous oxide, because it's a liquid, and whatever the pressure gauge is showing is the vapor pressure. Vapor pressure remains as 745 psig till probably the last part of the liquid is evaporated. Only after every drop of nitrous oxide is evaporated, then the vapor pressure, if you continue to use, then the indicator will start falling. So that's why initially they thought that there is no requirement of a pressure gauge, but later they considered that once the indicator starts decreasing or showing a reduced pressure, now you know that there is nitrous oxide is completely, the liquid is into the vapor state, and there is a chance that after some time you may have to change the nitrous oxide cylinder or to open a new cylinder. That is why presently we do have the pressure gauge for nitrous oxide cylinder. Now, another question they'll ask you is calculation of the contents of an E-type cylinder. So it is basically based on Boyle's law, which states that, already I told you, pressure and volume are inversely proportional to each other at constant temperature. So the formula you use is P1 V1 is equal to P2 V2. So using this formula, you can say that, at 1 atmospheric pressure, you can have with an E-type cylinder 660 liters. Suppose I'm using 3 liters per minute, I can use this for 220 minutes. Whereas with the nitrous oxide, so again, it will be asked for you in the exam. So nitrous oxide is a liquid, so it won't obey the Boyle's law. It obeys the Avogadro's hypothesis, because Avogadro's hypothesis, it states that 1 gram molecular weight of any gas will give almost about 22.4 liters at standard temperature and pressure. This is again important. Standard temperature in the definition is 0 degrees centigrade or 273 kelvins. So now you have to calculate actually at 293 kelvins how much of nitrous oxide is available, because we know that the molecular weight of nitrous oxide is 44. Then based on the Avogadro's hypothesis, we know that 44 grams of nitrous oxide will yield about 22.4 liters. So that is at 0 degree or 273 kelvins. So if I want to calculate for 293, I have to use the Charles law. So here, by using the Charles law, at 273 kelvins, it is 22.4. Now at 293 kelvins, how much? I got 24 liters. So now we know that 44 grams will yield 22.4 liters. So each gram will yield about 0.55 liters of gas at 20 degrees. Now we have, I told you that it is roughly about 3.3 kgs when fully filled nitrous oxide cylinders. So 3.3 kgs is 3,300 grams. So 1 gram will yield about 0.55. 3,300 will give you about 18-15 liters. So a full E-type cylinder, if you are using, so if you're using at 3 liters per minute, you can use it for 10 hours. So these are some of the common questions that are asked for you in the exam. So that's the reason why I have included these things also. So when all the liquid is turned into the vapor state, so then it obeys the Boyle's law, and usually once the indicator starts falling, you still will have about 250 liters in a E-type cylinder to be used. Now I was telling you about the pressure gauges. These pressure gauges are color coded. You can see they are color coded. And another very important safety features of these pressure gauges, they are in front, they are constructed by a very tough glass. So if there is a sudden increase in the pressure and the seat tube breaks, so the gases will not come out through the front. So they open up only inside. So that is going to prevent some amount of injury to the persons standing in front. So in modern machines, we may not, some of the workstations do not have these pressure gauges. They use the pressure sensors, and digital display of the pressures will be there. Like in this, you have the digital display of oxygen, air, nitrous oxide, and the cylinder pressures are also being shown because the cylinders have been closed, so it has been showing as 0. You may not have the pressure gauges as such. Now coming to the last part of today's discussion is the pressure regulator. So you know that the pressure what we use in the cylinder is a very high pressure, 2200 psi of oxygen. So these pressure regulators are constructed based on a basic principle, that is pressure is equal to force divided by area, or force is equal to pressure into area. This is the basic principle on which these are constructed. This is a direct acting pressure regulator, wherein the high pressure inlet falling on a small area, entering a large area. So once it enters a large area, because pressure force is equal to pressure into area, if you keep the force constant from above, so the pressure has to come down. So that's how the outlet pressure will decrease. So what are the functions of the pressure regulators? Because this is another question that is asked. So many times when you are asked, you will tell in the first thing as it prevents barotrauma. No. You should not tell that as the first important function of the pressure regulator. What you should always tell is it provides a constant pressure and flow of gases to the flow meters. Let us just imagine, suppose the pressure regulator is not there, you are using 2000 psi of the cylinder, and I'm keeping about 3 or 4 liters of flow of oxygen. After say a few minutes, the pressure in the cylinder starts falling. So because the flow depends on the pressure, the flow also starts falling. So my job will become only to keep on adjusting the flow of oxygen or nitrous oxide there. So that is the reason the presence of the pressure regulator will provide a constant low pressure to the flow meters so that the flow is kept constant. So that is the main purpose of using the pressure regulator. Of course, the other functions are like prevention of wear and tear, fine needle valves, and prevents barotrauma to the patients. So this is an indirect type of pressure regulator. Now here you have the high pressured gases are entering, and they are pushing a valve with a small area. You have a return spring also here. This return spring is connected through a valve thrust pin to another spring which has got a higher force than this return spring force. So because of that, this valve is kept open. So the gases can enter into a larger chamber and they can fall on this diaphragm of a larger area, and they can, the outlet pressure is always decreased. So if you want to calculate, these are some of the equations are there. So if you want to know more about, you can read Dash and Dash. Beautifully, it has been explained, and I don't want to go into details about these, the calculation of these equations. So because they, quite a bit of time I've already taken. So one more thing about this thing is the regulators is the older machines, you have this master and slave regulators. So master being oxygen and the slave regulators used to be the nitrous oxide. Usually there are 3 chambers. Many times you are asked about this particular the slave regulator of nitrous oxide. No, there are 3 chambers, 1 chamber here, 2nd chamber, and the 3rd chamber. So the oxygen has to flow and has to apply pressure to open the nitrous oxide flow. If there is no pressure of the oxygen, the nitrous oxide cannot flow. So it's you can see here in this right side, the oxygen is flowing inside because of the pressure of oxygen. Now I told you there are 3 chambers. This is one chamber wherein the oxygen is flowing into. So that is compressing a diaphragm. This diaphragm is attached to a spring, and that is going to compress. This is the middle chamber that is going to compress another diaphragm, which is connected to a valve thrust pin. So this pin comes down, and because of that, nitrous oxide can flow into the lower chamber. So, and then only the nitrous oxide can flow out. So in the left side, there is no oxygen supply, no oxygen pressure. So, the thrust pin has completely occluded the flow of nitrous oxide. There is no flow. So that's this is the type of valves. These are called as the slave valves for the oxygen. This is a nitrous oxide slave valve. Now this thing I'll just stop. So this is my lecture on the high pressure system. So next week I'll be talking about the intermediate pressure system and also the low pressure system. Probably I'll be telling more about the differences between the GE machines and other machines when I talk to you about the intermediate and the low pressure system. Sorry, Rajesh and Giri have taken almost more than 1 hour. So I hope there is no problem for Sudesh and Rakesh. Thank you so much.
Thank you, sir. We should really thank you. No problem for the time taken. I think the students are most benefited, and they can again rehearse it in the ISA Kerala YouTube channel. And so, do you want to take up the questions in the chat box? I can see a few questions there.
Yeah, definitely.
Yeah, and before going to the question and the answer session, there's a couple of announcements. And there are a lot of academic activities coming in next week, 26th Friday. That is at 8 p.m. There is a talk by Dr. Saikant Sengupta. That's regarding patients with liver disease for non-hepatic surgery. It is hosted by ISA Palakkad City branch and jointly conducted by ISA Kerala also. And on 27th, and next session is on 27th, that is on Saturday. And please note, it is 6 p.m. sharp. We will start Gurudat sir's next session on Anaesthesia Workstation, and followed by a case presentation by a postgraduate student from Baby Memorial Hospital, Dr. Smera Manoj, and the external examiner is Dr. K. Vinodhan, and the internal is Dr. E.K. Ramdas, HOD, BMH Calicut. And again, there is one more session, third session, that is how to face practical exams in the current scenario by Professor Mobarak sir. So can we go to the chat box and go to the question and answers?
Yeah, sure, Rajesh.
Yeah. So there's a first question by Dr. Sharada. That is material used to manufacture cylinder in India.
Same molybdenum steel.
Molybdenum steel, yeah.
Yeah.
And another is a question by Dr. Sheikh Majid. Could you please explain what is tech test?
No, tech test is usually done for the pipeline. See, I told you there are quick couplers are there, and you connect the pipeline onto the wall outlet. So after connecting to the wall outlet, you have to do some, you should apply moderate force to try to take the pipeline out of the connector. So this is called as a tech test. So it should not yield.
Okay, sir. Thank you. And there is another question, but I could not understand. Can you repeat the slide? Which slide? I don't know. There is the name of the student also is not there.
So they can see later.
Yeah,
the slides, all the slides are there. Will be there in the YouTube.
Yeah, sir.
That was about the nitrous oxide cylinder, sir. When sir was discussing about the nitrous oxide cylinder, especially with respect to the filling, the absence of flow meters for nitrous oxide, especially in the older machines. So when he was giving a pressure gauge, sorry, sir. Yeah. That was the slide which they probably didn't understand. I think if they go through that YouTube, it is anyway recorded there. Probably they will be able
because it is usually filled based on the filling density. or filling ratio, not by using any gauge, because the gauge will always show 750 psi, whatever it is filled inside.
So there is another question. Please explain high altitude relation with the nitrous oxide cylinder usage.
Nitrous oxide as such, even if you are using nitrous oxide in the high altitude area, what is very important here is, when you use the flow meter, I'm going to talk about these flow meters and how it will change, especially for higher flows, because higher flows obey the Graham's law and the density. The density of nitrous oxide will come down as you use it in the high altitude area. So you may have actually the higher flows than what you have set, because these are calibrated at 760 millimeters at sea level. So actually you may have higher flows. That is why you have to calibrate the the flow meters at that altitude. Otherwise you may have hypoxic flow.
Thank you, sir. That's another question. In manifold, what cylinder is present?
The H-type cylinders, the largest cylinders.
Yeah. And another question is, nitrous oxide is a liquid. What causes it to vaporize on its own? What causes it to become gas?
The temperature. It is always the temperature. That's the reason, after some time, if you just touch the cylinder when you're using, it will be very cold, because it is using the outside temperature. And, many times there can be frosting of the water vapor on the cylinder also. Then, the gauge may actually show a little bit less, because the inside temperature may come down and the vapor pressure also will come down. So if you just stop using, then after some time, the gauge will come back to its normal 750 psi.
And there's another question. I noticed that there was a fluctuation in pressure gauge in pressure regulator while using ventilator mode through cylinder. What would be the reason?
Now, usually there should not be any fluctuation in the pressure gauge when you're using, because now we have the flow restrictors are always there, and check valves are there. So once you are using the check valves and the flow restrictors, the back pressure effect is very, very minimal. So I think you'll have to call the technician or the company fellow and check the thing. There may be some fault.
Thank you, sir. That was no doubt it was an excellent presentation. There was a lot of congratulatory measures in the chat box from the faculties and students, and hope we'll hear you more in the upcoming PG updates also. Definitely next week there's a lecture by you. Thank you so much, sir.
Yeah, actually, Rajesh, I always feel very happy when I give lectures or talk to the students.
Yes, sir.
So I always feel very young when I speak to the students. Always, that is the reason why I always want to be with the students. Thanks for the opportunity, Rajesh. Thank you.
Thank you, sir. That's why your name meaning is generous teacher, no? Gurudat. Okay, sir. Any comments from the faculties? Sir, anything to add, sir?
Sir, as usual, this is Dr. Sudesh.
Joined us.
Yeah, Dr. Sudesh
joined us.
Yeah, Dr. Vijesh. Dr. Sudesh.
Sir, good evening, sir.
Yeah.
At the outset, I'd like to thank the Kerala ISA for giving me this wonderful opportunity to be on the this PG update program. And I just went back to my PG days 13-14 years back when Gurudat sir was my teacher. He used to stand beside us and dissect the anesthesia machine, those days the Boyle's machine, and teach each and every component of the machine. Especially now it's a time constraint, but then there was no time constraint. We stood almost 3 hours and we never knew how time passed. Like 3 hours, it was a beautiful brainstorming session regarding anesthesia machine. Thank you so much for taking us down the memory lane, sir. Thank you so much. Gained a lot of information also again. It was as good as like attending our PG class, like during our PG days.
Thank you, Sudesh. Thank you.
I'm sure many of them would have the same feeling in the group, probably.
Right, Sudesh.
So Dr. Vijesh has joined. Dr. Vijesh.
He left again.
He had joined, maybe left. Yes.
Can we go to the next session?
Yes.
Yeah, we will move on to next session.
Over to Dr. Rakesh and Dr. Sudesh. Dr. Rakesh, please. Dr.
Yeah,
Sudesh.
thank you so much, sir. Thank you. We are moving towards the part 2 section of the statistical tools. It is an important aspect for all postgraduate students from various multitudes. So they are doing a dissertation, so they should be knowing it. Even the theory exam at times contains short questions, and even in Viva OC when something is being asked. So if it is in the context of good understanding of the statistical tool, it becomes much more easier. And the most important is in the present era, when we talk about the evidence-based medicine, the critical appraisal of published literature is very, very important. So in continuity to the last month statistical session we have done, so we'll continue this time, and I will request Dr. Sudesh Kannan to start on the important aspect of understanding the various variables. There are so many words we use, so many numbers we use. So how to quantify them? Why do we sometimes say that it is having a quantity or it is having a quality? Why are they required? How they are important from the statistical tool, from statistical point of view? So I will request Dr. Sudesh Kannan to take it forward. Over to you.
Thank you, Rakesh, sir. Is my screen visible, sir?
Yes.
visible.
Yeah.
As said by Dr. Rakesh Garg, we will be moving to the second session of the statistics session. So in the previous statistics session, we discussed about the methodology of study regarding various questions which can be asked in the exam, such as blinding, allocation concealment, randomization technique, sample size estimation. And these things were discussed in the previous class, as well as some of the methodology, like how to conduct a study, how to prepare a methodology was discussed in the previous class. Now, once the methodology is done and you have collected the details, everything, now how do you compile it together and prepare the results out of this information what you obtained from the study? So that's what we are going to discuss in brief today. So the next 20 minutes or so, this particular session basically has divided into 3 parts. That is a part 1, which is where we are dealing with what do you mean by data, what do you mean by variables, what are the different types of variables and how are they measured. And secondly, the part 2 is how to confirm that the data is uniform or not uniform, and if they are uniform, how to go about. And if then next, what are the different types of statistical tests available and what are their choices, and what do you mean by p-value and confidence interval and their importance. And finally, the part 3, where both myself and Rakesh sir will be jointly handling the session, where we will be trying to present the interpretation of the results and how to present the results. So with this, we'll move to the topic. So just to start off, because most of the time if you start with a word or it will be dry and it might be difficult to follow, we'll just start off with practically with a simple example. Like we are trying to do a study where we are trying to study the effect of duration of analgesia with addition of 150 micrograms of clonidine intrathecally to hyperbaric bupivacaine in adult patients undergoing knee arthroplasty under subarachnoid block. So if you notice, it's a study which is trying to assess the duration of analgesia, and of what? It's about the addition of clonidine to bupivacaine. If you add bupivacaine, what happens to the duration of analgesia? And in whom? In patients who are undergoing knee arthroplasty. So according to this, so in this study, obviously the control group would be patients who receive plain bupivacaine, and for the sake of uniformity and for the sake of blinding, we add 0.5 ml normal saline to that to make it a volume of 3.5 ml, whereas the control group, where the study group or group clonidine will receive 0.5 ml of clonidine, which contains 150 micrograms, and 3 ml of bupivacaine. So what are the parameters what you are going to study? The primary outcome, as we discussed, as it is glaringly visible in the title, It is the duration of analgesia, and many times many secondary outcomes can be noted, which include the duration of sensory block, motor block, incidence of effect on hemodynamic parameters, incidence of hypotension, bradycardia. All these things are usually the secondary outcomes. So when you collect all these data, then we try to enter all these things into one of the commonest used tools is Microsoft Excel sheet. So we know that Microsoft Excel sheet is something like a sheet where you can enter all the parameters and then enter those parameters in the sheet, and you can do a lot of basic calculations in the sheet itself. So this Microsoft Excel sheet, we generally what we do is we just put we give the headings such as serial number, name, age, sex, IP number, ASA, what is the indication of surgery, then what is the mean arterial pressure, basal, then duration of analgesia, hemodynamic parameters you mentioned, like mean heart rate at the time of basal, 5 minutes, 10 minutes, 20 minutes, like that. For every parameter, heart rate, SBP, DVP, MFP, for every parameter you just go on entering the data on the, you make a heading on the top of the sheet, and you go on entering the data in the various columns. Okay, and finally this is something what you get. So basically you mentioned that you concise the entire data what is entered in this sheet is actually finally compromised or compressed into small numbers which represent the entire data set. So this is, for example, age, the gender, the weight, and the body mass index, then ASA physical status, duration of surgery, and then the study parameters, that is duration of analgesia, duration, sensory and motor block. So basically they're compressed into a single number. The entire group of data are compressed into a set of single numbers. And what are these numbers and what are they called is what we are going to study in this particular session. So basically, if you notice, these are correct, valid measures and which are very specific to study. If you just go through the headings in the previous table, they are basically correct, valid measurements which are valid for studying that particular outcome measure, and they are specific to the study, and they are not randomly named or randomly measured. So these are the these parameters are the ones which are observations of interest whose value can vary in the study. So if you notice, these age, gender, ASA, mean arterial pressure, all these things can vary in both the groups depending upon what is added and what is not added. So therefore, these are the variables because they can vary in the study because of your intervention. So that's why they are called as variables. So when we describe these variables in the result section of an article or a manuscript, basically you describe when you apply statistics to these parameters, they actually are put in two types of statistics. One is descriptive statistics. As the word implies, it is about how do you describe that group of data, or in what way you present that group of data. And the second one is the inferential statistics. Inferential statistic means where you apply certain statistical tests on this group of data to infer about an outcome or to generate some meaningful conclusion out of that data set. What I am going to discuss in the first part is the descriptive statistics. So when you mention about variables, we just discussed about variables, like what are the variables. These variables are broadly classified into two types. One is quantitative or numerical, and the second one is qualitative or categorical. The quantitative or numerical is measured on a numerical scale, and it is quantified in the form of a number. It might be an integer or it might be a decimal, whatever it is, it's usually quantified by a number. Whereas categorical is defined by certain characteristic or quality, and it cannot be quantified. You have to make some assumptions to quantify them. For example, if you the quality of anesthesia, you can either mention good, satisfactory, or bad. There is nothing like you can measure. If you want to measure, you have to put in a scale. So that way, quantitative and categorical are the two broad classifications of variables. So if you see this, there are so many variables. See, age is one variable, gender is one variable, ASA physical status is one variable, duration of surgery is one variable, sensory motor block is one variable, and PONV is one variable. Each of these variables have got different characteristics, and they are classified as quantitative and qualitative based on their nature. So, for example, age is a quantitative variable, gender is a qualitative variable. Again, all these, if you see the black colored ones, they are all quantitative variables. The ones which are labeled in black are quantitative variables, whereas those which are colored blue, for example, the gender as well as the ASA physical status, they are actually qualitative variables. Quantitative variables are further subdivided into discrete and continuous data. What do you mean by discrete? Discrete usually take a countable number of values or distinct values, and usually the scale units are usually limited to integers. If you see the examples of a discrete data, example is number of patients admitted to a hospital, number of asthma attacks per year, number of hospitalizations per year, or anything like that, where, for example, you cannot mention number of patients to admitted to a hospital cannot be mentioned as 2.5 or 3.5 because they are complete numbers. So usually they are limited to numbers. So they are known as discrete. For example, episodes of vomiting, you can mention 2.2, 3, 4. There's nothing like 2.5 episodes of vomiting, 3.5 episodes. So these kind of data are known as discrete quantitative data. Next is continuous data. Continuous data is data which can take any value or a particular range. For example, if you see here, the scale units are not specific to integers, they can also have decimals. For example, height. Height can, suppose somebody, you cannot say that somebody's height is 150 centimeters or somebody's height is 160 centimeters. Between 150 and 160, it can be 151, 152, 153, 154, 155, anything. But if you actually go further and if you refine your measurement, it can be 151.5 centimeters, 155.2 centimeters, anything. It can take any number. It can be represented in any number, which can also have a decimal. So that's why these are known as continuous data. So examples include height, weight, age, body temperature, etc. Because it's not a single intermittent value, but it's a continuum of values. It can take any value from, for example, if you consider body temperature 36 and 37, it's not only that much. Anybody, the body temperature can be 36, 36.1, 36.2, 36.3, 36.4. Likewise, it can take any number. So that's why they are known as continuous data. So if you can just see the example, if you go through the previous table again, so the age, all these parameters, age, weight, BMI, duration of surgery, all these parameters are known as quantitative continuous data. That's why if you see, there are decimals here, okay? Whereas if you see the last column, that is the number with PONV, the fraction of patients who had post-operative nausea vomiting. This is known as discrete data because they are in fractions or in specific numbers. So you cannot mention that the incidence of PONV is 5.5. That means only 5.5% had PONV out of 50. So it's usually a discrete number. So this is known as discrete data. So now we have understood what are the different broad types of quantitative data or numerical data. Next, we'll go to qualitative or categorical variable. Again, qualitative or categorical variable, as we discussed, it is actually which are not measured or which are not measurable, but they can be grouped for specific for standardization purposes. So when they are grouped, there are two types of these categorical variables can be further divided into two types. One is nominal and second is ordinal. What do you mean by nominal and ordinal? Ordinal, the word itself says order. It is basically they have a particular order. Usually they are measured in categories and they are ranked in grades. For example, if you just take a pain score itself, when you talk about VAS score, you from 0 to 10 is the VAS score. So if you want to quantify the pain or if you want to grade the pain, you actually grade them as mild, moderate, severe based on, for example, 1 to 3 is mild pain, 4 to 6 is moderate pain, and 7 to 10 is severe pain. So thereby, if you notice, they are following a particular order. For example, somebody who is having 1 to 3, he will be classified as mild pain only. He cannot be put as moderate or severe because you have a particular sequence in which you have to segregate them. So this kind of arrangement is known as ordinal categorical variable. Likewise, for another example is ASA grade 1, 2, 3, 4. See, ASA can be grade 1, grade 2, grade 3, grade 4. Okay. So again, it is based on the severity of the disease, underlying disease. Somebody who is having grade 1, his underlying disease is he's absolutely normal patient other than the surgical disorder. Whereas grade 4, he has got severe comorbid illness. So likewise, Bromide scale of motor block, all these things are ordinal scale. Nominal include, there is no order. Basically, they are actually falling into individual groups based on their characteristic. For example, if you consider blood group AB or O. So a person can have A blood group, a person can have B blood group, or he can have AB. He can have any one of them. He cannot have multiple of them. So these kind of arrangements are known as nominal categorical variables. For example, if you see gender, male or female, blood group AB, O, or even, for example, presence of a disease. Somebody says if the disease is present or not, then you have only two answers. It can be yes or it can be no. There is nothing in between. So they are also known as nominal categorical variables. So if you see here, again going back to the same table of the study, if you see the gender distribution, male and female, 30:20. So this is a nominal variable, whereas as a physical status 1, 2, 3, 4 is basically a what kind of variable? It is a ordinal variable. Likewise, motor block is a ordinal qualitative variable, whereas age, weight, BMI, duration of surgery, all these things are continuous quantitative variables. I hope this is understood. Okay. So to summarize, so variables are basically classified into qualitative or categorical, or quantitative or numerical. So among the qualitative variables, it's ordinal or nominal. Ordinal, basically they are arranged in particular order or graded or categories. For example, severity of the disease, age, for example, child, adult, old. For example, the recovery from disease, better, same or worse. Cancer stages, like stages of cancer, grading of cancer, grading of motor block, all those things fall under, and grading of your Malampati class, all these things fall under ordinal. Whereas nominal include gender, blood group, treatment groups. For example, group A, group B, they are nominal categories. Outcome, for example, death or alive. These kind of things are known as nominal variables. Likewise, now coming to the quantitative variables, it can be either discrete or continuous. Discrete, for example, specific integers in the form of examples include number of patients admitted, number of asthma attacks, number of deaths in an area. Whereas continuous variables include your pulse, BP, hemoglobin percentage, age, weight, height, BMI. These are some of the examples of continuous variables. Now we have understood the type of variables. It's not rigid that all the variables are represented at the same time at all points of time. The variables, the representation of variables can vary depending upon the circumstances or depending upon the outcome what you are expecting from the study. For example, you just take this example, smoking status as one of the variable. So if you want to represent, if suppose if the study is biased by the smoker versus non-smoker, then this becomes categorical nominal data. For example, smoker versus non-smoker, because either he smokes or he doesn't smoke. So these are only two categories. So this kind of arrangement is known as categorical nominal data. The same thing, if you want to assess the severity of smoking on a particular outcome, then you classify them based on the degree of amount of smoking. For example, somebody smokes 10 cigarettes per day, you classify them as heavy smoker. Somebody smokes about 5 cigarettes per day, classify them as light smoker. Somebody who has stopped smoking 6 months back, you classify them as ex-smoker. Somebody who doesn't smoke at all is classified as non-smoker. So this kind of arrangement where you follow a particular order is known as categorical ordinal data. And finally, suppose you want to quantify the amount of cigarette smoked between two groups. For example, let us say you are trying to compare the incidence of cancer, lung cancer in patients who smoked, who were heavy and light smokers. So in that, if you want to quantify the data, what you do is you collect the data as number of cigarette smokes per day. See, in this heavy smoker, you mean that anybody who smokes more than 10 cigarettes per day is considered as heavy smoker. But you actually, if you see, you don't know how many. Somebody is smoking 100 cigarettes also, he is a smoker. Somebody is smoking 20 cigarettes also, heavy smoker. But you don't know the impact of the smoking on particular disease. So if you want to quantify that, you actually count the number of cigarettes smoked per day, then it becomes discrete data. Because for example, you mentioned 10 cigarettes per day, 20 cigarettes. Here you are actually measuring the discrete numbers. This is known as discrete data. So if you understand, each study will have more than one type of data. So if you see here, See, if you again going to the same table, if you see, you will have nominal data, you will have ordinal data in ASA physical status. And if you go for a duration of anesthesia, duration of sensory and motor block, they all form the continuous quantitative data. And if you see the PONV incidence, then that forms the discrete data. So this is about how you understand a variable. Okay. Now, methodologically, if you decide, if suppose if based on the study methodology, if you try to classify the variables, there are two terms, that is independent variables, that is dependent variables. All these variables, whatever we discussed till now, they can be either independent or dependent depending upon the study. So before understanding the intricacies of that, we'll just go through what do you mean by independent and dependent. Independent variables are those which are varied or manipulated by the researcher. So for example, if you take the previous example, in the previous example, we are discussing about what do you say, the intervention as addition of clonidine. So this addition of clonidine is an independent variable. So group A clonidine group and group B control group, these are the independent variables, because this can be manipulated by the researcher. The researcher decides to put clonidine or he decides to put him onto the control group depending upon the randomization sequence. So therefore it is independent. It doesn't it is not influenced by the outcome. Whereas dependent variables are those where the responses that are measured. Okay. So the responses which are measured because of manipulation or intervention by the researcher. For example, if you go back to the previous example, if the independent variable is addition of clonidine, whereas duration of analgesia is the dependent variable, because this duration of analgesia is influenced by addition of clonidine or not, by adding clonidine or not adding clonidine. So therefore, independent variable causes change in the dependent variable, whereas it is not reversible. It's not the vice versa. Dependent variable will not cause changes in the independent variable. So I was just discussing about the same thing in the previous slide. So likewise, giving you a few more examples, let us see this example. Comparison between two different laryngoscope blades, that is McIntosh and Miller blades, in terms of time to intubate, number of attempts, trauma, and hemodynamic response. Now, what is the independent variable? The independent variable is McIntosh blade and Miller blade, because these are the ones which are introduced by the researcher, or these are the manipulations which are introduced by the researcher. So they are not influenced by the outcome. Whereas time to intubate, duration of number of attempts to intubation, and trauma, these are the dependent variables, and these are the ones which are influenced by independent variables. Going to one more example, effect of age, gender, and weight on duration of pre-oxygenation with regards to change in saturation at 1 minute, 3 minutes, and time taken to reach a saturation of 100% from baseline. So this is the study. So what is the independent variable? The independent variable is age, gender, and weight, because the author can, or the researcher can, select the age group. He can select the gender in whom he is going to do the study, and he can select the weight band in whom he wants to decide to do the study. Whereas the time, the change in time saturation from baseline at the end of 1 minute or at the end of 3 minutes of pre-oxygenation is totally dependent upon the intervention, that is pre-oxygenation. So therefore, they are all dependent variables. Time to required to reach saturation of 100% is again a dependent variable. So we just discussed about two types of variables. Now there is something called confounding variable. Now what do you mean by confounding variable? Confounding variable is one which is actually present. It's something like if you see if an agriculturist is sowing paddy in the field, along with paddy there are some weeds which are growing inside the paddy. So these weeds are basically present and which can influence the growth of paddy, isn't it? So confounding variable is something like that. So confounding variable is a variable which is inherently present in the study group as well as the control group. And it can influence the effect of independent variable on dependent variable. That means it can modify the output, or it can modify the outcome of the study. So this is known as confounding variable. So if you go to the example, if you see again going back to the same previous table, control group and clonidine group, they are independent variables, whereas motor block, duration of analgesia, sensory block, motor block, All these things are dependent variables. Now, if you see the age, the gender, the weight, body mass index, and the physical status, all these things can affect the outcome of the study. It can have a bearing on these parameters. For example, so if females are more, they can have a females and males, they can directly influence the incidence of POMA. Okay, likewise, obese and non-obese with respect to weight and BMI, they can also induce some sort of what you say confounding in the outcome. Suppose obese patient will have a longer duration of motor analgesia, or they might have shorter duration of sensory block, they might have shorter duration of transit. So therefore, all these things can have direct or indirect bearing on these outcome variables, and therefore they are known as confounding variables. I hope this matter is driven through. So dependent variable, independent variable, and confounding variable. So all these are basically variables. They are either quantitative or qualitative depending upon what they represent, and based on the point of view of the research question or the study, they can be either independent variables, they can be confounding variables, or they can be dependent variables. I hope the message is driven through. So once we have understood the data, and now next thing is we are going to enter it into the master chart on the Microsoft Excel sheet. So before enter it and taking it up for statistical analysis, there is a small step, something known as pre-processing of data or data cleaning process. What do you mean by this? Basically, what you are doing to do is, before, as we know, when we try to cook a food or something, we actually, when you prepare a rice, when you are going to cook rice, you actually try to segregate all the impurities in the rice before you take it for cooking, or you take it for the final stage of cooking. So likewise, in data also, data cleaning process, what you do is you remove some of the unwanted or some of the data which are present, but they are not going to contribute to the outcome of the study, or they are going to disturb the appearance of the study. So this is known as data cleaning process. What you do is basically you reconciliation. That is, you cross query the data entry. Many a times what happens, there might be missed data, or there might be double entry, or so many things can occur. So all these things, in order to avoid these things going into influence the final results of the study, you just reconcile or reconciliation, or just go through the data, cross verify that with the protocol paper, whatever you have entered, and you verify whether value. Many times it so happens, I have seen many master charts, including my own students, including mine. Many times, instead of entering NIBP 1, 2, 3, like was for let us say systolic blood pressure, instead of entering 1, 2, 3, I would have mentioned 1, 1, 2, 3, because it's just sheer by a typing error. So that would, if you see the mean, automatically the mean will go up like very high when you calculate, when you try to calculate mean from this particular data series. Okay, so therefore you cross verify the data and then try to eliminate the duplicate entries. Sometimes you might be able to find the missing data. Many times some of the boxes may not be entered. It might be not be entered due to completion of the study, or sometimes it might be missed while entering. So you try to find out all those things. And detection of outliers, this is one tricky situation where many times, let us say you have included 20 patients in your study. The duration of analysis in, let us say 1 to 10, patient number 1 to 10 is 2 hours, 4 hours, 3 hours, 3 hours. Likewise, suddenly one patient has a duration of analysis of 15 minutes, and whereas the other patient has duration of analysis of 9 hours. So if you see, most of the patients have duration of analysis ranging between 2 to 4 hours, whereas one patient has got 15 minutes and the other patient has got 9 hours. These wide changes are basically due to some of the inherent involvement in the patient, or sometimes it might be due to some erroneous entry. Sometimes there would be some while entering, somebody would have not entered properly, or some problem would have occurred while entering, or sometimes it would have not been proper monitored. So these are known as outliers, and you try to find out why the outliers occurred. If it is occurred due to the in spite of all the taking the best precautions, then you can continue using that. Or suppose if you have if it is due to some negligence while data entry from the patient into the protocol sheet, so you can omit such kind of things. So now that you have entered all these things, you are going to measure them and quantify them and represent them in a graphical way or tabular way, whatever it is. So you represent the values using various mathematical models. Usually quantitative variables are expressed in the form of mean, median, mode, and standard deviation range and interquartile range, which I'm going to discuss in the subsequent slides. Likewise, qualitative variables are expressed as proportions, percentages, and ratios. So in this, if you see age, all these black colors, they are quantitative variables. They are expressed in the form of mean and standard deviation. Likewise, qualitative variables, that is gender distribution as well as ASA physical status, they are expressed in the form of ratio or percentages. Okay. So most of the times the data may be uniformly distributed around a central value, or sometimes the values might be spread out within a particular range. For example, as I discussed earlier, see, if you describe the duration of analysis, some patients had 2 hours, 3 hours, 4 hours, some had 3.5 hours, some had 2 hours, like that. Suddenly one patient had 5 hours, one patient had 10 hours, one patient had 15 minutes. So this kind of distribution can occur. So they can be widely scattered or they can be concentratedly scattered. So you have to describe that in a particular pattern. So that pattern is known as measures of central location, where it is represented by a single value that best represents the characteristic of the data, which is usually mean, median, or mode. And the next is measures of dispersion, that is how much a value can move away from the central value. For example, let us say you have a mean of so we just discussed about the standard we just discussed about the duration of analysis of a patient group, like 2.5, 3.5, 4.5 hours and on. So if you take the mean, let us say the mean is around 2.5 hours. So the mean 2.5 hours is a single value that represents the entire characteristic of data, whereas let us say the standard deviation is, let us say, around 1.2 hours. So this 1.2 hours is the one which shows the spread of data. So it says that a data, if you put 1.2 on either side of 2.5, that is 2.5 minus 1.2 is 1.3, and 2.5 plus 1.2 is 3.7. So most of the around 60 to 70% of the values lie between 1.3 and 2.7 hours. So this is what the measures of dispersion imply. Normally, the measures of dispersion are measured in terms of standard deviation, standard error, range, variance, and percentile. Now, what are these? Measures of central tendency. Mean. Mean is the arithmetic value of the series of data, whereas median is the middle value in the series of data. And mode is the commonly occurring value in that series of observations. Then measures of distribution. One is range, where it is the difference between the minimum and maximum samples. For example, if you go back to the same example, the range is 15 minutes to 9 hours. If you see, 15 minutes is the lowest one and 9 hours is the highest one. So therefore, this is the measure of dispersion, but it doesn't give much of a meaning. Likewise, so when you orderly arrange them in a particular fashion, and then you divide that into 100 equal parts, then it becomes percentile. So usually you mention 25th percentile, 50th percentile, 70th percentile, or any other percentile. And the most second common use of measure of dispersion is interquartile range. What do you mean by interquartile range? It's nothing but you arrange all this data in a particular ordered fashion. Let us say you first take the central value, and then you see how much each value differs from on either side of this central value, and put them accordingly on either side of that central value, and you generate a curve. So the one which lies between the 25th percentile and 75th percentile, this is where the most of the values lie, and this is known as the interquartile range. And the middle of the interquartile range represents the median. So whenever you use median, you use interquartile range. Standard deviation is a standard, this one which is commonly used, and it is a measure of variation or dispersion of a single value from central value, and it is usually calculated by the standard formula. Most of the time, these formula are self-fed in the Excel sheet, and if you use the commands, standard deviation, etc., you can straight away calculate the values from the Excel sheet itself. And variance is another measure of spread out of the distribution of variables in a population. So now you might be thinking where to use, how to use these things. When to use mean, when to use median, when to use range, percentiles. For that, you need to understand one more concept, that is allow the location of or the spread of data, which is usually described by a Gaussian curve. This will be described much more in detail by Dr. Rakesh Garg, but meanwhile, I'll just introduce this point to you. What you need to understand is there is something called Gaussian curve, and the center of the Gaussian curve represents the mean, median, or mode, and on either side represents the depression. So what you do is you just mention, you calculate the mean, plot it in the center, and go on plotting all the values on either side of the center line. What you get, and finally you just contact all the lines and you make a curve, and this is known as a Gaussian curve. Based on this Gaussian curve, if they are symmetrical, then the data is uniformly distributed. If they are not symmetrical, they are not uniformly distributed. Whenever there is uniform distribution of data, use mean as the mode of representation of data. When there is non-uniform distribution of data, or when they are skewed, you use a median as a representation of data. Okay, so you don't enter mean and standard deviation. In fact, you enter median and interquartile. Likewise, measure of distribution for uniformly distributed data, you use standard deviation and standard error. Whereas for skewed data, the measure of dispersion commonly used is range and interquartile range. So this completes the variables and data thing. Just to add one sentence, next is how to, once you have calculated all this, how do you represent it in the result section? Data can be represented in various methods. One of the commonest and easiest methods is textual pattern. You just go on writing the text, like the duration of, you can mention so many patients were included in the study, and the age duration was so and so, the age in this group was so and so, age in group was this one. So this is the textual matter. The other method of representation is tabular format, and the other method is graphical format. So then how do you use various table or graph is based upon this small table. For example, most of the categorical use either table or graph, bar graph or histogram. For numerical data and continuous discrete, you can use bar or histogram, whereas continuous data, most often we end up using line graph or box and viscous plot. Likewise, correlation, you use Kaplan-Meier curve, and for diagnostic test, you go for ROC curve or receiver operating curve. Thank you for your patient hearing. Hope I didn't take much of your time. I think exactly half an hour. Over to Rakesh sir.
Thank you, sir. Thank you so much. Can you just allow me to share the screen, Dr. Sudesh?
Yes, sir. I'll stop. Sorry. Yeah.
So thank you again, the ISA Kerala branch, especially Dr. Venkatagiri, Dr. Binil, and all the ISA dignitaries for again giving the chance to interact for the statistical concepts. Dr. Sudesh has also already very nicely described about the various variables. But now when we say so much of variables, we need to describe them, and statistics is basically the data reduction. And then try to put them into a very meaningful way so that we can summarize the data and then compare it. So this is what the statistics is, and we have discussed all in this last session also, and we have discussed in this session also. And we also discussed something about descriptive statistics and inferential statistics. Descriptive, Dr. Sudesh has already mentioned very nicely that how to use the descriptive statistical tool. Now, when we do a statistics, basically you need to understand that what are we comparing with, so to have a meaningful result out of it. So if you're just seeing for one variable, it will be univariate. If you're using more than two, it will be multivariate variables. So it all depends upon the type of study you are doing it. So if you have multiple data, multiple groups, more than two groups, or you are comparing data at multiple times, it will depend upon the study design. The suitable statistical tool will be used for this. And as you mentioned that the variables are either categorical or quantitative. So when you describe them into a statistical analysis, categorical data are usually formed in the form of frequencies and percentage, and the quantitative data are in the form of mean and median. And if you are using mean, you have to mention standard deviation. And if you are using median, you need to mention the range or interquartile range. Now, this is important because most of us are familiar with range. So we mention median with range, but we forget to write interquartile range. So whenever you think that median is being used, I'll tell you where it is being used. In that situation, the interquartile range must be mentioned. Also in the categorical data, one important point which we miss majority of time, we try to put percentages with every number. For example, say the total sample size was 50 and you have say 30 number into one group. So we'll keep n is equal to 30 in bracket, we'll keep 60%. So remember, when the frequency is 100 or less than 100, there is no need to put percentages. Try to use percentage only when the number crosses 100. So whenever it is less than number, maybe the event rate, maybe the total sample size, maybe the occurrence of any measurable value that you are doing it, it should be, if less than 100, just mention the number without a percentage. More than 100, mention the percentages also. Now, these are the things that will show you the measures of central tendency, and how to use them will depend upon the Gaussian distribution, which Dr. Sudesh was also mentioning. Now, this type of distribution, now if you have data and you put them onto a graph and try to outline the whole data with a line, and if it takes the form of a bell-shaped, it becomes a Gaussian distribution. Now, this distribution we expect will happen if you have done your study very nicely. It is a blinded study, it is a randomized study, there is no bias. Most of the data should be Gaussian distribution, and that is the acceptable gold standard distribution of your data if everything has been fine. Now, this bell-shaped curve has been used with different terminology. Some people say it is symmetrical distribution, some say it's Gaussian distribution, some say it's normally distributed, but it all means the same. So whatever it says, it's a Gaussian distribution. But in case if you see the data and place them onto the graph and try to create a line, this situation can happen in some of your data. Either it could be, your data could be skewed, it will not be a bell shape, it will be skewed towards the left or towards the right. So it could be left skewed or right skewed. This means when you see your data of a Gaussian distribution, the mean, mode, and the median are overlying each other. But in the skewed data, the mean is onto the left of the median, and here on the right side, mean is right of the median or the mode. So these type of skewed data usually happens if there is a very small study or there is some possibility of error or bias, or there is lack of randomization, and that can lead to this skewing of data. But sometimes it can happen genuinely also. So if your data is skewed, then the various statistical tools are less robust. So we want that the Gaussian distribution or the symmetrical distribution should be there, because then we can apply the statistical tools which are more robust. But what can we do if they are having a data something like this? So one is, if you want to assess your data, you can see these graphs, do a eye rolling, and then you can say that it is skewed data or non-skewed data. They are similarly, you can ask your statistician to help you out, and they can apply certain tests like Kolmogorov-Smirnov or Shapiro-Wilk test. Now they will tell you using these tests that whether your data is Gaussian distributed or non-Gaussian distributed. So this will help you. Now this is important because the statistical tool for Gaussian distributed data and non-Gaussian distributed data are different. So that's why it becomes very, very important to understand the distribution of your data. Similarly, on a very rough note, you can see the difference between mean and median. Now, if you see, for example, in this study, the difference between the mean and median was 1.5%. On the other hand, when we talk of the length of stay, it was 29.1%. So in case if the difference between mean and median of your study is more than 5%, this means the data is non-Gaussian distributed, because as we have shown in the earlier graph, the mean will not coincide with median, and if it is further far off, then probably your data is not Gaussian distributed. Now, as I mentioned earlier, that Gaussian data has a better validity. You can apply a robust statistical test, and the conclusion is more robust. But since the study is completed, if your data is non-Gaussian, they will be having a lesser robust statistical tool to apply. So what we can do in this situation? The option is either we apply the parametric test, which are, as I mentioned, are less robust. Their conclusivity is much less. You cannot very strongly conclude that one group is better than the other group, or the complication rate is more than in one group as compared to the other group. The other option could be that you can transform to normality for the purpose of applying statistical tool which are having more strength. Now, transforming means you can do a log transformation of these data and then check whether they are having Gaussian distribution. Then you can apply the parametric test. But if they still remains non-Gaussian, or you don't want to apply normality data, then non-parametric test needs to be applied, but then they have less robustness. The other aspect is if your data is Gaussian distributed, then you need to report your descriptive statistics as mean and standard deviation. In case if your data is non-Gaussian distributed, you need to mention median, range, and interquartile range. So that is how you need to differentiate where to mention mean and where to mention median. Sometimes we see ourselves that we mention both mean and median and range also. So you remember that if your data is normally distributed, no need to mention the range. A mean standard deviation is more than sufficient. So you should not be mentioning range along with it. But on the other hand, for non-Gaussian or non-symmetrical data, you apply median and do mention range and interquartile range with this. Let's see this example here. So suppose this is the study where they have compared two type of blocks here, sciatic and tibial blocks, and they have found some data. Now, if you see here, as I mentioned earlier, since this number is less than 136, they have not mentioned the percentages here. This is one aspect. Now, probably the distribution of the A's was showing a Gaussian distribution. That's why they have applied mean and standard deviation. Had it been non-Gaussian distributed, they would have seen the median and range. So with mean, they have not mentioned the range. So this means this data was Gaussian distributed, and that's why they have looked for the quantity variable and did a descriptive reporting in the form of mean and standard deviation. Now, since the same study in which they were looking for the numerical rating scale, so they found that it was a non-Gaussian distribution. So that's why they have used the median here. And remember, when they are reporting median, they are reporting the IQR and range also. So this is important to report your median along with IQR range when you are reporting a non-Gaussian distribution of data. Now, coming to the inferential statistics, that is when you want to compare what you have obtained from your data. This is what we do. Now, in case of a bivariate analysis, we need to take 4 decisions. The first is the data that you are doing it. As we have already discussed in the previous session by Dr. Sudesh, you can have a data which could be categorical or quantitative, and you want to compare that data as compared in one or the other group, whether they are having some statistical significance or not. So based on the type of data that you have or that type of variable you have, you can have 3 combinations: categorical versus categorical, categorical versus quantitative, quantitative versus quantitative for your comparison and statistical analysis. Now, when you do a comparison, you just need to remember these 4 important points. Now, these are important ones. And based on this, you can easily take decision that which statistical tool or test will be applied. First is combination of variables. Second is normal or not normal data that you have in the 2 groups. The number of groups you have, that is 2 or more than 2 groups. And the variables that you have noted, whether they are related or non-related. I'll come one by one. Now, combination of 2 variables, we have already seen the variables, so we know what variables we are using. We have already seen this chart as nicely explained by Dr. Sudesh. So we know that whether we have categorical or numerical data. Categorical is also known as qualitative data. They are meaning same. Quantitative is also known as numerical, so they mean the same. Now we have already discussed what do you mean by normal or not normal, Gaussian or non-Gaussian distribution. You must be aware of it, and you can use the statistical tool of normality for checking this. Third is based on your group study or your study design, you know how many groups you had, 2 groups or more than 2 groups. Related versus unrelated means whether your study design was matched or before after study design, or there were 2 independent groups. For example, as Sudesh also mentioned in one of his study, that in one group there was fentanyl, another group fentanyl plus clonidine. So they are two separate groups. They are not related to each other. But on the other hand, if you do say a pre and post laryngoscopy hemodynamic measurement, so it becomes a related group. So based on this, you can take a decision. Now, you know these four factors, and based on this, we can apply this statistical tool. Let's see one by one. Now, suppose the first we say that both the groups were categorical and you want to compare them. For this comparison, if you know that you have two groups or more than two groups, in case if there are two groups and they are, whether I just mentioned related versus unrelated, in case they are unrelated, there are two independent groups as per the study design, you can apply the chi-square or the Fisher-Exact test. In case if they are related, means pre and post, or you are doing a matching, you need to apply a McNamara test. I'm telling you test because when you report your dissertation in the statistical tools that you applied must be mentioned. So you have to mention that variable A was compared with variable 2 using this test. So if you know this knowledge, you can easily apply test. And similarly, if you see a critical appraisal of your paper, and if you found that the appropriate test has not been used, so the p-value does not carry any significance. So you cannot make any confusion because the wrong tool has been applied. Now, in case if the number of groups are more than 2, if they are unrelated, you can apply the chi-square test or Fisher-Exact, and for related McNamara. So when both the data are categorical, irrespective of the number of groups, the test application will be chi-square, Fisher-Exact, or McNamara. Now, out of the chi-square or Fisher-Exact test, two tests are being mentioned. If you think the group that you are comparing, the sample size or the number of patients are less than 30, or if you are measuring some event rate, like for example, the occurrence of hypotensive episodes or the occurrence of bradycardia episodes, if such number of occurrence of episodes are less than 5, then you will be applying Fisher-Exact test. If they are more than this, you will be applying the chi-square test. Now, the second type of combination that we can have when you want to compare categorical versus quantitative. For example, length of hospital stay in two groups where one receives the epidural block, one receives the IV analgesia. So this will be categorical versus quantitative. Now, I will be now, as I mentioned earlier, parametric versus non-parametric, since we have quantitative data here. So if you have a Gaussian distribution and the number of groups are 2, if they are unrelated, you use student t-test. If they are related, you use pair t-test. But in case if the number of groups are more than 2, means you are doing a study where there are 3 groups being compared or more than 3 groups, more than 2 groups being compared. If they are unrelated, use one-way ANOVA. If they are related, use repeated measures ANOVA. Now, on the other hand, if the quantitative data of the group is non-Gaussian distribution, and if there are 2 groups, if they are unrelated, you need to apply Wilcoxon rank sum, also known as Mann-Whitney. And they are related, then you can apply Wilcoxon signed rank test. For more than 2 groups, if they are unrelated, you can apply Kruskel-Wallis, and if they're related, you can apply Friedman test. Now, these are the only tests which will be applied in majority of our studies when we do them. And this needs to be reported into your last section of your method section, that this variable was normally distributed as has been compared using this test. So this becomes very, very important for you to mention. Let's see some example to understand them much better. Now, for example, this was a 2-group study. You can see group control and group clonidine, where in which one group we have used hyperbaric bupivacaine, and another group we have used hyperbaric bupivacaine with clonidine. So these were the 2 groups of 50 patients each. Primary outcome was duration of analgesia, and secondary outcome was duration of sensory block and duration of motor block. Now, when we find these observations, for example, we want to compare, say, age. Now, age is, if you compare this data, the groups are categorical, but the age has a numerical value, so it's a quantitative value. So when you want to compare categorical versus quantitative, which could be age here, which could be weight here, BMI, and the duration of surgery. So all which are mentioned in black here are the quantitative data. So now when we want to compare categorical, the groups are categorical versus quantitative data like age, weight, BMI, and duration of surgery. Now, if you know that your distribution is normally distributed, because if it's a mean, this means this is normally distributed, you will apply student t-test. If it was not normally distributed, you would apply median here, and then you will apply man-Whitney test. So this is how you have to take the decision of which way of describing your data and which statistical tool to apply on. Similarly, when you talk of categorical, like for example, gender versus two groups. So it will be categorical versus categorical. Similarly, the ASA physical status here. Now, in this situation, you will be applying chi-square test because there is no quantitative data here. So you will be applying chi-square test here because the sample size here is more than 25. Now, similarly, if you talk about the primary outcomes here, duration of analgesia, which is again quantitative. So categorical versus quantitative data, parametric, student t-test, and non-parametric. If this duration of analgesia was skewed distribution, you need to report them into median with range and interquartile range, and then the statistical tool that will be used will be the man-Whitney test. So this is how you need to apply. But now in case if there are three groups, right? The first is control, second is with clonidine, third is dexmedetomidine. If you see, these three groups are independent groups, right? And there are three groups. Now, when we have three groups, if they are, for example, we are comparing the gender here, then in that situation, we will apply chi-square test. But in case we are comparing, say, for example, age or maybe weight here. So we are comparing categorical versus quantitative, but there are three groups. They are unrelated because they are independent one. So depending upon whether this data is normally distributed or not normally, if they are normal, we'll apply one-way ANOVA. If they are not normal, we'll report them as median, range, and interquartile range, and we'll apply the Kruskal value test here. So this is how you can use even for other parameters, other objectives that you are using it. So to summarize here, when we say the application of statistical tool, you need to plan your statistics at the study planning itself, which we discussed last time in the form of sample size, and you can involve this statistician from the planning stage for you helpful. And then we'll come a little later that interpretation should be done very cautiously in these patients so that the things becomes much more easier. So this is what we have learned, the application of statistical tests. I've just tried to give you the information which is required for your reporting in the dissertation or when you're sending the paper for publication. This much information is mandatory to report. Otherwise, your paper will come back with a rejection or with a revision. So this is what needs to be done. So any questions till now?
Thank you, Dr. Rakesh Kar. Can we go to the questions in the chat box?
Yeah, sure.
Is the first part of statistics available on YouTube? Yes. All the programs will be uploaded in the YouTube. Dr. Binil is there. He can answer.
Yeah, even our YouTube link is shared in the chat box. They can just click on the link and they can subscribe our YouTube channel also. All our programs are there in the YouTube. Almost 20 lectures are there.
So, Dr. Sudesh, can you just explain it that what is standard error and why do we say a standard error rather than the mean or the standard deviation that we are using? So how to differentiate these two aspects?
Yeah, thank you, Rakesh sir. Actually, I was just, this was the same question asked by one of our other participant also. So basically what is standard error is, see, it is the difference in the means, or it's the difference in means when you, for example, I was just giving an example of, let us say we are taking a population of a particular city. Let us say Alapura or Alapi. So we have a population of about, let us say around 20-30 lakhs. So you're trying to study the effect of a particular drug there. Let us say the effect of, let us say the effect of antihypertensive in that particular population. We cannot go on testing the entire 20-30 lakh patients, give them medications and test. So what we do, we select around 100 patients from that. So that 100 patients is known as a sample size. And we give the medication. So before giving medication, we measure the blood pressure. After giving the medication, we blood pressure. So you find the difference. So the difference you calculate from that, you take difference from each patient and take a mean of it. So that forms the mean. Okay, and you calculate standard deviation from that mean using that formula whatever I showed in the slide. So this is mean and standard deviation. But many a times this mean is not is absolutely representative of the means of all the patients. So if you try to repeat the same test in another set of 100 patients, you leave this 100 patients and take another 100 patients from that population of therapy, and you give this antihypertensive, the mean whatever you get from that set of population might be different from this set of population. So this difference in mean is nothing but the standard error of means. So when you go on testing 100, 100, 100, you take 5 sets of 100 patients and take the mean difference in blood pressure before and after medication. The means what you get in group set 1 will be different from 2, will be different from 3, will be different from 4. So this kind of the difference in these means is known as the standard error of mean. The smaller is the standard error of mean. That means the means are very closer. That means whatever you are anticipating the effect is almost very predictable, or it is very consistent. That is what is inferred by the standard error of mean. If the standard error of mean is wider, that means the means are wider. So therefore there is a possibility that the values in the general population, when you try to generalize the findings of this particular study into general population, you might not get the same desired value as you get in this particular study. So that is the implication of standard error of mean and mean. I think Rakesh sir, you can add few more points regarding standard error of mean in this.
I think you have nicely described here. So majority of time when we are doing a single study, we are just giving them the standard deviation here. But if you do a multitude of samples and then try to report them, then it becomes a standard error of mean for that particular different samples. So there are no more questions right now. So we'll have just a couple of more slides when we say the results interpretation, the last section, which we're supposed to discuss. So if Dr. Rajesh allows us, if the time permits, can we take another 10-15 minutes?
Sure, sir. You can, please go ahead.
So the last aspect when we talk about the results interpretation, or what we'll say the pitfalls of hypothesis or misinterpretation of hypothesis, this is important. Now, when we say the p-value, so majority of time when we say we have achieved a p-value of say p.01, we think that the two groups are having a statistical significance, that I agree, but we also interpret them that the group A1 is better than group B. So this is one of the important things when you try to interpret your results based on the p-value. So statistical significance does not guarantee clinical significance. Now this is very, very important, because when we write the discussion section, we need to be very careful. Let me take you through this example. So for example, say time taken for tracheal intubation is CMAC video laryngoscope was significantly less as compared to glide scope, and P was 0.01 in patients with normal airway. So this appears that one video laryngoscope was better than the other because P was 0.01. So should we interpret something like this? No, we cannot compare like this, because if we see the magnitude of difference, for example, the time taken was 14 seconds in one and 18 seconds in the other for a normal airway. Though the p-value is 0.01, but it does not carry any clinical significance. So we cannot say that one video laryngoscope is better than the other video laryngoscope, because the difference of 4 seconds does not have any clinical significance. So your discussion section will be heavily based on the clinical expertise. But same time, if your study population was a patient with ARDS, where the oxygen reserves were too low, in those situations, we can obviously say that even 4 seconds may be of some significance. So you can just interpret your result accordingly. So this is one of the important points. And I just repeated again that statistical significance does not guarantee clinical significance, and your acceptance of results and your discussion section must emphasize this. The other aspect is p-value is not sufficient. The confidence interval also needs to be looked for, because P is just a measure of the effect of occurrence of something by chance. So if we say it's 0.01, say the occurrence of this difference by chance will be less than 1. So this is what by mean p-value. So we need to look for the confidence interval, because p-value sometimes we say highly significant, not significant. But as I mentioned, it does not guarantee clinical significance. What we need to look for is the confidence interval. Now, nowadays, if we see any of your studies, the confidence interval is being reported along with the mean standard deviation, for usually for the your objectives that you are using, and they should be mentioning the confidence interval means the boundaries of the whole data within the 95% will give you the estimate of the collected data that you have. For example, if you see this study, they have mentioned the 95% confidence interval of mean difference. So if you can see here, now in next subsequent slide, I will try to explain it. Now, if you see the intubation success rate at first attempt, it was 76 in one group, 73 in another group. So maybe even if this value is having some statistical significance, but if you see the mean difference, it is crossing from negative to positive side. So possibly it does not carry any clinical significance as such, even if it has some significance on the statistical aspect. So try to pay attention to the effect size of the confidence interval. For example, I will come back to the same which I've shown you earlier. If you say the CMAC was 14 and the glide score was 18 and the 95% confidence interval was this much, we earlier mentioned the p-value was statistically significant here, 0.01. But if you see the data here, since they are overlapping with each other, so probably the difference in the values of the two groups does not have any significance also from the data point of view, because they are overlapping each other. So that's why we cannot say that one video laryngoscope provided a faster intubation rate as compared to other. We cannot say very sure, because the data of 12 to 18 is overlapping with 14 to 20 seconds. So even though the p-value was 0.01, even the data was not giving surety of the definitive outcome, and that's why we should be very, very sure. So this means the p-value will independently is not the predictor, or we can say in a simple language, is not the justifier for saying that group A is better than group B. We need to look for the confidence interval, and we need to look for the clinical significance. The second aspect which is important is the association does not equal causation. Suppose we find something into a study and say it's a statistical significance, we should not be interpreting them by saying that this has caused this. So you should be very cautious in the discussion section. The third problematic thing is the data dredging or the multiple testing, or in a simple language, we sometimes use the subgroup analysis or multiple subgroup formation and their analysis. Now, this type of data dredging should be avoided until unless you have a priori to start with some definitive area of interest or a group of interest, then you can think for. And there are multiple studies. For example, this is an interesting study, which is in 1980s, where Yoke randomized almost 1,100 heart patients. They didn't get any intervention. They just divided the patient into 18 subgroups, and they tried to find out the significance. Since they have done nothing, so there is not there is no expectations of something difference coming out of it. So that's why. But surprisingly, they found that in certain groups, the p-value was significant. So when they have done nothing, how the difference can exist? Because every patient was being treated in a similar fashion. So this is the lacuna of doing multiple testing and subgroup analysis that is to be avoided. So don't try to torse it data long enough that it confesses what you want. It gives you significance in some of the small group, which is having no significance. So that should be avoided, because the reason here is, when we try to increase, because if you remember in the last session, when you talk of sample size, we have put up a significant level of 5% or alpha of 0.05 here. So when you do a multiple testing, by applying multiple tests in the same data, this 5% error, which was acceptable to us, crosses much more. It becomes 10 and 15%. And that type of error or that much of error is not acceptable in the statistical language. So that's why multiple testing should be avoided here. So this is what we need to understand about our clinical data and various issues that can happen that will help us to interpret the data more effectively. Over to you, sir.
Thank you, Dr. Sudhish Kannan and Dr. Garg, Rakesh Garg. And that's statistics is a difficult topic for the postgraduates as well as for the faculty members. And a lot of faculty members attended the sessions, the last session and this session. I think it will be benefited for those for appearing for practical exams and those who want to take research work seriously and to publish following the research work. Thank you, sirs, Dr. Rakesh Garg and Dr. Sudesh Khanna. We are fortunate to have two experienced faculties in the topic. And over to Dr. Binil and Dr. Venkadagiri and Dr. Nazar.
Thank you, sir. First of all, we appreciate the presence of our past national presidents, Dr. Chakra Rao, sir, and Dr. Balabhaskar, sir. And we could also appreciate the presence of so many HODs from all over India.
You tell President also.
Before I moving on to vote of thanks, Giri sir, any comments from you?
I have a comment. It is like blind people explain. I will have to learn a lot statistics. Full statistics I have to learn from Rakesh and then I don't understand really, but they have taken a good class and all.
I have a comment.
Again and again.